Alright, hello Science 10, Mr. Beeland here with your lesson for today. We are talking about measuring energy, okay? So, remember, energy is the ability to do work. And work is the ability to apply a force to move or change something. So, energy is the ability to apply the force to move or change the objects, right? And energy can also be used to maintain processes, right? Keep things moving or going however they are going. So when we're measuring energy, we're going to be looking over here, and the unit for energy that we use most often is called joules, okay? So joules is our standard unit, and it tells us a whole bunch of different things because there's a whole bunch of different types of energy, right? So one of the first ones would be how much work is being applied to move an object across a certain amount of distance, right? This would be like mechanical energy. Could also be used to tell you how much energy is stored when you lift something up, right? You're having to deal with gravity, right? How much energy is being required to lift up this pen? Could also tell you how much work is being applied to a charge to move through a circuit. Or it could be used to determine the amount of energy in sound waves. Or it could be used with chemicals, right, in chemistry, when you're trying to find out how much energy is in the bonds of your molecules or inside your nucleus, right? So there's a whole bunch of different things that joules covers, right? And this makes sense because we can, and you're going to see this down the road, you can convert things from one type of energy to another. Right? Of course, there's always going to be some loss and stuff like that, but you can convert, so the units still kind of have to be the same, right? In order for them to be able to move across nicely. This unit, the joule, this is your primary unit. So if you ever see two things referring to each other, you always end up your final unit being joule, okay? So the two other examples, the two minor examples are calorie with a lowercase c and calorie with a capital C. These are also units that we use for energy, but if it's being referred to in combination with joules, then our final answer is going to be in joules. So what is a calorie and what is a calorie? Well, this mostly has to do with food. This is where it comes in the most, okay? And you'll see that this kind of ties in almost a little bit with like thermal energy. Remember when we were talking about the specific heat capacities? This seemed pretty closely connected because a lowercase calorie, which would be represented by CAL, all lowercase, is how much energy would be required to increase 1 gram of H2O by 1 degree Celsius. Seems pretty familiar. The other one, calorie with a capital C, and this would be written as capital C, lowercase al, this is how much it would take for 1 kilogram of water to be increased by 1 degree. Still the same idea, right? You're still looking at kind of like the specific heat capacities and stuff like that. It's very similar. And, you know, generally the reason why we have this other version instead of this one is because very rarely do you deal with things so small, right? You'd have lots of decimal places or really large numbers, and so just using a larger unit with kilograms just makes things a little bit easier, right? Okay. So the last thing we have to talk about here, and our last unit, is power, okay? And power is how much energy is being used up per second. It's the rate of energy consumption, okay? So it is in joules per second. The formal unit for power is called watts, and you can write that with a big W. This is most commonly used when dealing with electricity. You'll notice when you go home, or if you're at home, you'll see that things have a certain wattage, right? Your light bulbs are a certain wattage. You'll have a meter outside of your house that has the ability to keep track of how much wattage you're using, right? So that is how much energy is being used per second. So 1 watt equals 1 joule of energy in 1 second. Okay? And then from there, as you increase the wattage, the number of joules would go up, okay? That's pretty much it for the overview of our lesson today. Please have a look at the reading passage and the homework questions, and we'll just dive in a bit deeper there. Let me know if you have any questions. All right, take care.